Assalamu alaikum class. I hope you all are doing fine. So today we are going to discuss the cache mapping with examples. So you will understand what type of question you will get and then how you are supposed to design and map the cache accordingly. So for example, let's say that you get a question like I am telling you that you have 1 GB RAM, right? So well, you have 1 GB RAM. Then I'm also telling you the word size. So I'm saying that word size in RAM is going to be 4 bytes. So word size is 4 bytes. You are supposed to make the blocks inside the RAM. So you're going to make the blocks inside the RAM. Then you're also going to design the cache accordingly as well. And then you have to answer the following question, like maybe I give you something like this, that what is going to be the physical address of this word 69. Then obviously if I'm asking you about a certain word, I'm also asking you that in which block it's going to be stored, and then when you do the cache mapping, in which line number it's going to be stored. And you are supposed to perform the calculations. You're not supposed to do it like quickly or shortly without performing the actual calculations. So let's start the solution for this question. So let's say that I'm just going to solve that specific question. Let's start with the RAM size. So my RAM size is, as I told you, my RAM size is 1 GB. So if I'm giving you a 1 GB RAM size, it simply means that I have 1024 MBs in the word. It means I have 1024 megabytes in my RAM. I'm always talking about megabytes. It's not about bits. If it's all about the megabyte, first thing I'm going to do is I'm just going to find out how many words can be stored inside my RAM, because the data is going to be stored in the form of the words, and I have given you the word size. If I give you the word size, you're supposed to follow that specific word size. So let's say that I'm saying the first calculation you performed is about checking that how many bytes you have inside your RAM. If you are given already in the MBs, then you already know that the whatever is given to you is already in the bytes. But for example, if it's not like that and I'm giving you something like in GBs, so you are going to find out how many bytes it's going to be converted into. Later on, we are going to find out that how many words are going to be stored into this. So the size of the word, I have said that the size of the word is 4 bytes each word. If it's going to be 4 bytes each word, I have to find out number of words. So if it's 1024 bytes and my each word is of 4 bytes, so I'm totally going to have 256 words inside my RAM. It means I can store 256 words inside my RAM. If I can store 256 words inside my RAM, it means my words are going to start from word 0, word 1, word 2, up till word 255. This is going to be my all thing. You have to remember that always everything starts with 0 and ends with one digit before the ending thing. Like if it's 256, my last word is going to be 255. If it's 1024 words, it's going to be 1023 last word. But right now we don't have that much words. We just have 256 words. So word 225 is going to be my last word inside the memory, and it's going to start with word 0. Now later on, if we just we have decided this is going to be over words. Now we are going to make the blocks. We have decided the words. So we have 256 words already. So we understand that we have 256 words. Now we are going to make the blocks. Well, these calculations are pretty fast, not that much time consuming, but you're supposed to perform all the calculations. Now you're supposed to make blocks. Now you can see that inside the question, I did not told you that if you are going to have how many blocks you're going to have, if you're going to have like 128 blocks or 64 blocks, or make the blocks. Now for the blocks, as I have not mentioned anything that what's going to be the block size, how many words can be stored inside the block, it's totally your responsibility for the words and for the block. So for any type of calculations, you have to remember one thing, that you can only do these calculations in the pairs of like 2 or 4 or 8 or 16 or stuff like that. It's always going to be 2's raised to power something. So we are never going to deviate from these calculations. So now I am going to make the blocks. It means I have to store the words inside the block. If I have to store one word in each block, then it doesn't make any sense. Then why even I'm making the blocks? I can just keep the words as it is. It means blocks are made because we can store more than one word in it. Here, if you take two words in one block, it's totally your choice. You can do that, but I'm not going to do that. I'm just going to take 4 words in the block because I have 256 words. So what I'm going to do is, I'm just going to that I'm going to make the block size, like the block can have 4 words. So because a block can have 4 words, so I have 256 words and each block is going to have 4 words, which means that I'm going to have 64 blocks in total. So 64 blocks are going to store my 256 words. If I'm going to have 64 blocks, it means that I'm going to have from block 0, block 1, block 2, and up to block 63. As I explained earlier, it's going to be end at 63, not at 64. Now these are going to be my blocks. These are going to be my words. So I have found my words. I have found my blocks as well. So the next thing I'm going to do is I'm just going to see how the addresses are going to work for them. So if I'm simply going to make a table, in case if I make a table, so it's just going to be something like that. If I just roughly make a table for that, so you can actually make a table for these things. So this is going to be my first block. Let's say it's block 0. It will obviously have word 1, word 0, word 1, word 2, and word 3. Similarly, I will have next block. It will have word 4, word 5, word 6, and word 7. That's going to be block 1. And then similarly, I will have block 2, block 3, block 4, and it will go up to my block number 63, which is going to be my last block. So this is going to be my last block. And this block will have obviously the last words because my words are ending at word 255. And then word 254, word 253, and word 252. That's how the words are going to be designed inside it, block 2, and then keep on going like up till block 63. So in total, I have 256 words, 64 blocks. Now I want to see how the physical addresses are going to work for the words and for the blocks. So now I'm just going to see the physical addresses. So we will start from the words. So if I'm going to say that what is going to be the physical address for the words. So the calculation is very simple. How many words do we have? We have 256 words. 256 words mean 2 raised to power 8. 2 raised to power 8 means 256. Now 2 raised to power 8 means 256, which means we are simply going to take this 8. So it means my physical address is going to have 8 bits. 8 bits physical address. This is physical address for the word. I'm talking about the word. So the physical address for the word is going to be 8 bits. Now, if it's going to be 8 bits, how it's going to be written? Now, I think if you know how to do the conversions as we have studied in the conversions things, if it's 8 bits physical address, how we are going to quickly convert it. For example, if it's 8-bit physical address, let me just do it like this. Let me just insert a table for maybe 8. Okay, it's inserted a little up. Let me just drag it down. So we are just going to write down the numbers on it. the way we do. Let's say this is my 8-bit physical address. So how I'm going to convert it? I'm going to write 1 on the first, then 2, 4, 8, 16, 32, 64, and 128. These are exactly the 8-bit physical address. It's just like 1, 2, 3, 4, 5, 6, 7, 8 bits. It's exactly the 8-bit physical address. Now, whatever going to be the address inside is, inside this block, it's going to tell me which word I am talking about. For example, if right now in the question I asked you about word 69, that's what I asked you. That please tell me what's going to be the word 69. Let's say, how will you make word 69 in these 8-bit physical address? Obviously, you will put 1 under the 64. 64 uh 64, and then how many more things we need? Okay, we're gonna put 1 under this as well. It's gonna make 68. 64 plus 4, 68, and 1 under this as well. Now zeros under all the other bits. So this is my physical address for my word 69. If you want to tell me the physical address for word 69, so what is the physical address for word 69? So I'm just going to write down it like this. You have to do the proper addressing. Like the word 69's physical address is 01000101. This is exactly the 8-bit physical address, and you are supposed to do it exactly like this, the way I am doing it. You're not supposed to like quickly do it that I don't understand any of your calculation. It doesn't mean that I don't know the calculation, but it means that I want to know that if you're copying it from someone else, or you're properly performing all the calculations which are being taught to you in the class, and if in fact I'm teaching you these all things in the video as well. This is word 69. We understood how to find out the word's physical address. This part is done. Whenever you're done with one portion of your question, you're just going to highlight it. Like you can just, put it's inside a block to highlight it, that you actually find out the answer for the first thing. Now, once you're done with the word physical address, I ask you which block number. Now you can say, okay, we can find out the block number automatically, like just by making the table or stuff. But no, you're not supposed to do this. We are supposed to do this according to the formula. So if I am supposed to find out the physical address for the block, let's say if I'm going to find out the physical address for the block. So physical address for blocks, it's super easy. Physical address for the blocks is super easy. How? Now, how many blocks I have? I have 64 blocks. 64 blocks means 2 raised to power 6 is equals to 64. It means 6-bit is going to be my physical address. So physical address for the blocks is basically 6 bits. 6 bits is going to be the physical address. Now let's say if this is going to be the case that I have 6-bit physical address. Okay, let me just keep it like that. So if my block number is going to be 6 bits, I'm just going to take these first 6 bits, just these first 6 bits, and I'm simply going to take them down. Now I'm going to take them down, and I'm just going to say, okay, so because my block address is 6-bit address, so in my whole address which I got is basically divided in such a way that if you have a 8 bits address, so out of that 6 bits represent the block address or the block number. So the first 6 bits are 0, 1, 000, 1. These 6 bits represent the block number, not the last 2. When these bits represent the block number, now I'm not going to convert them exactly like I converted the words. The words were going up to 255, but my blocks are going up to 63. So how I'm going to do it? I'm just simply going to write them down exactly the way. I'm just going to insert a table for 6. Okay, like this. Let's say this is it. Now, because it's 6-bit, it's 0, 1, 0, 0, 0, 1. How I'm going to start it? 1, 2, 4, 8, 16, and 32. So what is my block number exactly? 16 plus 1, 17. So I'm having a block number 17. My word is going to be in block number 17. That's how it's going to work. Block number 17. Word number 69 is going to be in block number 17. This is my block number. Now, whenever we talk about the physical address as a whole, I'm going to tell you again, the physical address as a whole, if we again talk about the 8 bits, the physical address as a whole is that the first 8 bits, the first 6 bits, these 6 bits are going to represent the block number, and these last 2 bits are called the block offset, which actually tell the position of the word in the block, like in on which position that word is going to exist. So because our block number is 17, which is like 0, 1, 0, 0, 0, 1, and the last 2 bits are, I guess, again the 0, 1. I'm just gonna look at that again. That was, what was my block number? What was my word? Okay, it's 0, 1. So it's again 0, 1, which means how it's going to tell the position of the word. Now, how many words in each block we have? We have each block has 4 words. Each block. Now, we are just talking about one block. It means 2 raised to power 2 is equals to 4, which means each word has a 2-bit positional address. All right, so this is 2-bit positional address. So it means the 2-bit address is just going to represent in position 0, position 1, position 2, or position 3, whatever it's going to be. So if it's 0, 1, so how it's going to work? It's just like 0, 1. So on the top, I'm going to write down 1 and 2. That's how we are going to get, I'm sorry, it's just going to be 0 and 1. So each block is going to have 4 words, and so as we are having, each block is having 4 words. Now, right now we are just talking about the blocks. The blocks are having 4 words, which mean 2 raised to power 2. Simply, 2 raised to power 2 equals 4. It means I'm going to have a 2-bit positional address. So it's 2-bit positional address. So 2 bits positional address, what does that mean? That simply means that I have a table like this. It's going to be 1 and 2. If I put 0, 0, this is just 0, so it's word 0. This is 0, 1, so this is word at position 1. So if it's 1, 0, it's word 2. And if it's 1, 1, it's simply word 3. So we can have from word 0 to word 3. Like, these are the positions in the block. Every block can have position 0, position 1, position 2, and position 3. So if we look at these 2 bits, it's simply indicating that my word, which was word 69, it was inside block 17, and its position is at, I would say it is on the second position, because if you write it down in English, it's just a second position. So you can write down it as a second position, but you're going to tell how you identified that this is going to be the second position. This is going to be on the second position, or just like that. Now, after that, you have find out the block number and the position. Now you're supposed to tell that in which cache line it's going to exist. Now, obviously, we haven't designed the cache memory yet. So as we can see that our actual RAM memory is 1 GB. So if we have 1 GB RAM, Now we understand all the other things. We must have the same block size as the line size. In the cache we make the lines. So the line size must be equal to the block size, which means the number of words it's going to store. If the block is storing 4 number of words, the line is also storing the 4 number of words. So this is going to be always equal. Now, as we have the number of blocks, we have 64 blocks. So inside the cache memory, obviously cache memory is always a lot small than the actual RAM. So that's not an issue. So if we have 1 GB RAM, we can have a really small cache memory, like maybe 128 MB. Even if it's 128 MB, it's going to be fine. Even if it's smaller than that, it's going to be totally fine. But right now, it's totally your choice what exactly lines you are going to have. So let's say if I have 1 GB RAM, which means I have 1024 MBs for my RAM. So I will just say that my cache size is basically, let's say I'm saying 64 MB. Well, I'm again saying it's totally your choice. You can actually make it bigger if you feel like that you want to make it big. 64 MBs. I have word size is 4, so 64 divided by 4, I'm going to store 16 words, and each block is storing 4 words, so I'm going to have totally 4 lines. And the same thing, you would be confused that even in the class, and now we are just making the same lines like they are 4, but that's not exactly the fixed thing. Let's do it for the different thing. Like let's say if my size is 128 MB, I just decided that my cache size is 128 MB. If it's 128 MB, my word size is 4, so I'm actually going to store a total of I'm going to store a total of 32 words. And because I'm storing 32 words and each block or each line is storing 4 words, because my block size should be equal to my line size, so I'm going to have a total of 8 lines. So I'm going to have 8 lines. Let's say I'm having 8 lines. If I'm having 8 lines, what is going to be the address of each line? If it's 8 line, it means it's 2 raised to power 3 makes 8, which means my line's address is going to be 3-bit long, which means in 3 bits I can actually represent the line number. Let's again pick up the same address we were using for our word, which was word 69. So word 69 had this thing. This is the word size for word 69. Let me just copy this and we just paste it again, so we can just exactly find out where it's going to be existing. Okay, it's not being copied for some reason. I have to write it. Now this was my word address for word number 69. This was word 69's total word address. In that thing, we identified that the first 6 bits were going to be the block size. We identified what was the block, everything. Then we already know that this is going to be the position of the word. So leave it. This is the position of the word. This position is going to be same inside the block and inside the line, position of the word. Now what we're going to do is our line number has a 3-bit long address. So what we're going to do is exactly after the word position, the next 3 bits are going to indicate the line number where the block is existing. The line number where our block is. Once we know where our block is, we already know the position of the word. So 001, so I'm just going to put on the values on it. So it's going to be 1, 2, 4. So what is actually my line number? My line number is basically line number 1. 001 is basically line number 1. So now this tells me that actually my block number 17 is on line number. So my word 69 is in block 17, which is in line 1. That's how it's working. So we are all together having 8 lines like this: line 0, line 1, line 2, line 3, and so on. And each of them is going to have blocks, like it's going to have block 0, block 1, block 2, block 3, and so on and so forth. Obviously, there is going to be block 8. And then it's going to go exactly like this up till, and then it's going to have block 16. And obviously, this is going to have block 17. So block 17 is in line number 1. And inside the block 17, we are having the word 69. So we can actually see the block 69 as well, that if everything is working correctly or not. So let's see. We want to check if we understand that B17 is in line 1. We have identified it. Now, if B17 has word 69, we have to identify it as well. We did it with the formula, but we didn't, like cross proved it through the table. So let's say this is my block number 1. Let's consider that I'm just making the block. So this is my block number 0. This is my block number 1. This is my block number 2, block 3, block 4. So you can see that if I write down the words, it's just going to be word 0, word 1, word 2, word 3. Now later on, word 4, word 5, word 6, and word 7. Here again word 8, 9, 10, 11, then word 12, 13, 14, 15, 16. You can see actually I'm just using the table of the 4. 4 into 0, 4 into 1, 4 into 2, 4 into 3, 4 into 4. So basically it's actually a multiplication. So if I have to go to check if this is going to be in block 17, just multiply 4 with 17. What do I get? Block 17, 4 into 17 is word 68. So yes, word 68 is in block 17. So if it's starting with 68, obviously it's having 69, 70, and 71. So this is position 0, 0. This is position 0, 1. This is position 1, 0. And this is position 1, 1. So block 69 is at position 0, 1 inside block 17, which is inside line number 1. Exactly. So all the question I asked you and how it is totally proved is totally provable. So this is how you are going to solve your questions related to the cache mapping if you just get a question the way I told you. I know in the video it looks like that it will be like it would be done in 30 minutes. It's done in 30 minutes because I'm explaining it to you. But if you are doing it in your own, on your own, you wouldn't be kind of spending 30 minutes in solving just one question. But be careful that you are not supposed to do the shortcuts. I'm going to assess you on how you use the formulas and how everything is working. If you have any questions, you can just tell me. Another thing I just want to tell you that what if I give you a physical address in that? Like for example, just here in a quick way, consider that what if, as I know that I have this all things, so I understand that my words are going to be 256. That's something I already understand. So what if I just give you an 8-bit address? Like for example, I'm randomly writing some 8-bit address like this: 1 2 3 4 5 6 7 8. Let's say this is an 8-bit address. I give you the 8-bit address like this. I say this is the physical address. Kindly find out what is the word number, what is the block number, what is the position of the word, and what is the line number. So all of these things using this physical address. So what you're going to do is you're just going to pick up this physical address and you're just going to find out all these things. So I hope you understand. If you have any question, you can post your questions in the classroom. You can post your questions in the comments, and you can just let me know if you want to have any kind of help related to the cache mapping. So you can get, I will just simply give you exactly, I mean, these are the two type of questions I can give you. Like maybe even in one question I give you the both things. I also ask you, I give you the word number and then ask you all the other things, and I also give you the physical address and ask you to do the reverse engineering, like do all the stuff and prove it. Thank you so much.